In most quantity surveys, the Earthworks report is the primary deliverable. This allows professionals in the survey industry to report accurate quantities measured, their material, as well as the size of the area. Under the Reports drop-down, select Earthworks Report. You can only select the Earthworks report when a surface is included in the project. Here there are several options of how to create an Earthworks report. The first, based on a single surface. Second, comparison of two surfaces. And the third, comparing a surface to a predefined elevation. For this project, I will choose the stockpile depression report, as this lets me calculate a volume based on the surface, compared to a surface created by the outside edge of that surface. The second option, surface to surface, generates a volume based on the comparison of two surfaces. The third option, surface to elevation, compares your surface to a predefined elevation and calculates a volume from that. Here I'll select a surface that I would like to calculate a volume for. As well, it shows the classification. Beneath that, there is also a box to select a second surface, which would be used in the surface to surface option, and a box to input an elevation when using the surface to elevation command. You can also select a boundary to contain your volume calculation. The next option is to select the material type for the native and boro materials. These can be selected and created in the Materials Site Manager. The native material is classified as the material being excavated from the site, possibly for future use, and the boro material is considered brought from off-site. These materials can be the same type. The Materials Site Manager allows users to create and manage libraries of materials and site improvements for takeoff operations and calculations. TBC includes a sample library that can be a starting point for creating a user-specific material library. In this current project, we will not select a material, but the option is there if users would like to use materials in their Earthworks report calculations. The final option is to break down the volume by either a total value, a depth increment, or an elevation interval. This is useful for splitting up materials such as topsoil, subsoil, and gravel into different elevation sections. For this project, I will select the volume totals only option. In the report, the project information is displayed, including coordinate systems, date and time, and project location. The volume analysis section has the surface name and classification with the calculated volume. In this case, there are two quantities stated here. The stockpile volume is the area above the surface edge, and the depression is the area below the surface edge. As well, at the bottom of the report, there's any information regarding the boundary used to calculate the volume. One thing to note is that this report creates a comparison surface when computing volumes. This surface is called the ISOPAC by default, and it will show up in the Project Explorer under Surfaces. The ISOPAC is essentially a surface created when comparing two surfaces to create a value in the Earthworks report. This comparison is calculated by the prismoidal method, which compares the tin of both surfaces and creates a new surface. This is considered the most accurate method for surface comparisons and volume calculation. If you wish to keep this ISOPAC surface, you should rename it before creating a new Earthworks report, as it will be overwritten if it has the same ISOPAC name. Now that we've created an Earthworks report and are able to report on the total volume of the stockpile, we can look at documentation and project management tasks in regards to quantity surveys using SX10 data.